Hey everyone, and welcome back to the channel. Today we're diving deep literally beneath the Earth's surface to explore a fascinating and powerful phenomenon: how hot fluids inside volcanoes contribute to seismic activity and, ultimately, potential eruptions. If you've ever wondered why volcanoes rumble and shake before they erupt, you're in for a treat. This isn't just about magma. There's a whole lot more going on down there, and it involves some pretty incredible geochemistry and physics. So grab your metaphorical hard hats and let's get exploring. First off, when we talk about hot fluids inside a volcano, most people immediately think of molten rock or magma. And yes, magma is absolutely crucial. But it's not the only fluid playing a role. We're also talking about superheated water, steam, carbon dioxide, sulfur dioxide, and a whole cocktail of other gases dissolved within that magma, or even circulating in the surrounding rock. These aren't just passive bystanders, they are active, dynamic forces shaping the volcano's behavior. Think of them as the silent orchestrators of seismic activity. Imagine a giant underground plumbing system. At its heart is the magma chamber, a reservoir of molten rock. As this magma rises from deeper within the Earth, it brings with it incredible heat and immense pressure. But it's not just the magma itself that causes problems. As the magma heats the surrounding rock, any groundwater present gets superheated. This water turns into steam, and steam takes up vastly more space than liquid water. This volume expansion generates immense pressure, cracking and fracturing the rock as it tries to escape. These fractures are what we often detect as seismic activity, tiny earthquakes or volcano-tectonic earthquakes. They're not the massive, destructive quakes you might associate with tectonic plate boundaries, but they are crucial indicators. Think of them as the volcano clearing its throat. Each tiny tremor is a sign that fluids are on the move, pathways are opening, and stress is building up within the volcanic edifice. Scientists monitor these quakes very closely because their frequency, depth, and intensity can tell us a lot about what's happening underneath. A sudden increase in shallow seismic activity, for instance, might indicate that magma or superheated fluids are moving closer to the surface. Beyond just heating groundwater, these fluids also chemically react with the surrounding rock. Hot, acidic fluids can weaken and alter rocks, making them more susceptible to fracturing. This process, called hydrothermal alteration, essentially softens the rock structure, creating more pathways for fluids to move and making the volcano itself less stable. It's like rust slowly eating away at a metal pipe. Over time, it weakens the whole system. This weakening can contribute to landslides or even sector collapses, which can trigger eruptions or cause significant hazards on their own. Let's talk about the gases dissolved within the magma. As magma ascends closer to the surface, the pressure on it decreases. This drop in pressure allows the dissolved gases, primarily water vapor, carbon dioxide, and sulfur dioxide, to come out of solution, just like opening a soda bottle releases carbon dioxide bubbles. This process, known as degassing, is incredibly powerful. When these gases exsolve, they expand dramatically, increasing the volume and internal pressure of the magma. This expansion is a primary driver of explosive eruptions. The more gas that comes out of solution and builds up pressure, the more explosive the eruption can be. The movement of these gases and magmas can also create distinct seismic signals. We often hear about harmonic tremor associated with volcanoes. This isn't your typical sharp earthquake. It's a continuous rhythmic shaking, almost like a humming or vibrating sound. Scientists believe harmonic tremor is caused by the resonance of fluids, magma, gas, or steam, moving through cracks and conduits within the volcano. Imagine water flowing through a pipe, creating a specific sound. When this tremor starts or changes in character, it's a strong indicator that fluids are actively moving and potentially nearing the surface. It's like the volcano's internal engine is revving up. Another fascinating aspect is the role of hydrothermal systems. Many volcanoes have extensive hydrothermal systems, where groundwater is heated by magma and circulates through a network of cracks and fissures. These systems can be home to hot springs and geysers, but they also play a critical role in volcanic activity. Changes in these hydrothermal systems, like increased steam output or changes in water chemistry, can be early warning signs of deeper unrest. Sometimes a sudden release of pressure from a hydrothermal system can even trigger phreatic eruptions, which are steam-driven explosions that don't involve fresh magma but can still be very dangerous. So, how do scientists actually monitor all this? It's a complex puzzle. They use a variety of instruments. Seismometers are absolutely key, detecting those tiny tremors and harmonic tremors. GPS and tilt meters measure ground deformation, the swelling or deflating of the volcano as magma and fluids move within. Gas sensors monitor the type and quantity of gases being released, looking for changes in composition or flux. Satellite imagery provides a broader view of temperature changes and ground deformation over large areas. By combining all these data points, scientists try to piece together a real-time understanding of the volcano's internal plumbing system and predict potential eruptions. Understanding the interaction between hot fluids and volcanic activity isn't just an academic exercise. It's crucial for public safety. Early detection of changes in seismic patterns, gas emissions, and ground deformation, all driven by these internal fluid movements, allows authorities to issue timely warnings, evacuate communities, and save lives. This ongoing research helps us refine our predictive models and better prepare for these powerful natural events. It's a testament to how much we can learn by listening to the subtle whispers and rumbles of our dynamic planet. In summary, the next time you hear about a volcano rumbling, remember it's not just about magma. It's a complex dance involving superheated water, expanding gases, and the intricate plumbing system beneath the Earth's surface. These hot fluids are the silent architects of seismic activity, providing us with vital clues about the volcano's inner workings. It's an incredibly powerful system, constantly in motion, and one that scientists worldwide are dedicated to understanding more deeply. Thank you so much for joining me on this deep dive into volcanic fluids. I hope you found this exploration as fascinating as I did. If you enjoyed learning about the science behind volcanic rumbles and eruptions, please hit that like button, share this video with your friends, and don't forget to subscribe to the channel for more exciting content about our amazing planet. We've got plenty more to explore together. See you next time.